have more friction on the tires.
Is there more traction?
Yeah.
More traction. So this problem asks you what is the difference in the traction with and without that so-called airfoil or spiller. Alright, and it does involve something that I hope you remember from your physics, coefficient of friction. Just as a reminder, mu coefficient of friction is the traction force F. We call it tractive force in the problem statement F. And N, what do you think the N is? Normal. Normal forces is seen by the tire. So one case is without that upside down airfoil. In that case, with it, how much difference in the traction? Yes?
Is there a difference between what mu represents and what c represents?
Say that again.
Is there a difference between what mu represents?
Okay, this is very careful. This is not viscosity. It's a relatively poor use of nomenclature. But in your physics, this is called the coefficient of friction. Okay? This is nothing to do with fluid. I'm sorry?
Yeah, the same thing as like CF and CDF.
Okay. They're totally unrelated. First and foremost, let me clarify this one more time. In your problem statement, in this homework, you are given a coefficient of friction. I just happen to pick a very bad symbol, which is mu. That may confuse you with the viscosity. No, this is just coefficient of friction, just like you have seen in solid mechanics. All right, and that end right here. If you don't like it, maybe I should use a different symbol. Called theta. All right, it's only stand for coefficient of friction. Has nothing to do with the left-hand side. Okay, now we can ask the question on the left-hand side. You have a question on the CD and CDF?
Yeah, I thought that was also the coefficient of friction.
No, this is friction due to fluid. That is nothing to do with fluid friction over in here at all. Okay, that's just coefficient of friction as in solid mechanics.
So this is C of force.
Say it again, I'm sorry, C of,
C.
this is, okay, let me explain the nomenclature one more time. So all the C stand for coefficient, which is dimensionless number. So this C also stands for coefficient. This subscript F stands for friction coefficient, which is a shear. Okay? I can see why it causes some confusion in some of you. So this is not friction in forces. This is friction in shear stress, which is the unit of pressure. Can you see that? And hence it's normalized by half rho v squared. This coefficient is that of force, a drag force in Newton. This is in Pascal. And it's forces normalized by the pressure times an area. So this is coefficient of drag in force, which is in Newton or in pound force. And that's what this equation is. And totally nothing to do with coefficient of friction on the other problem statement. Totally detached. But this is a little bit of confusion as to what the CF and the CDF is. CF is a shear, CDF is a force due to friction. Is that clear? Okay, we'll take a short break, 2 minutes, and then I will